Okay, so in problem 3, a block of weight W slides down an inclined plane on a thin film oil as shown in the figure. The film contact area is A and its thickness is H. Assuming a linear velocity distribution in the film, derive an analytic expression for the terminal velocity of the block. Okay, so what do we understand from this question? When they say terminal velocity, V, do you mean what does this mean? In fluids, when we say, or in dynamics, when we say a terminal velocity, this means that we have reached the constant velocity state. So V will not change anymore. And if V is not changing, this means that the acceleration is equal to what?
0.
The acceleration is equal to 0. Okay, so this is why here we can say that to reach the terminal velocity V, we should be at the condition of 0 acceleration. So if we apply the second law of Newton, then we can say that sum of forces is equal to 0 in the direction of motion. Okay, so let us go back to our figure. We have a block that is moving downward on an oil of film of thickness H. Okay, and we know that sum of forces in the direction of motion should be 0. So the first step to do is to draw the free body diagram of the block. Are you familiar with what is a free body diagram?
Yes.
So I think you have already taken dynamics and statics. Okay, so I should draw all forces acting on my system. So if I want to represent the forces acting on my system, I have the weight of the block. So I have W, okay, and what I have also
friction, normal,
okay, I have the normal reaction
and the friction.
And the frictional one. And what is friction here? Friction here is due to what?
The normal, viscosity.
Very good. To viscosity, to viscous effects. Okay, so I have here the normal reaction. I have the shear. So here I will call it S. It's the shear force. Okay, and I have the weight. Now, I am interested in which, I am not interested in the direction that is perpendicular to motion, okay? Because I need to find something related to the velocity. So I will try to relate to the shear force. And the shear force is along the direction of motion. So I will apply my equation, sum of forces along 0, along the direction of motion. So this is my x direction here. My x is along motion, so this is small x. So now, if I want to say that sum of fx is equal to 0, then I should project my forces along x direction. For the normal, the projection is 0 since n is perpendicular to x, so I don't care about n. Now I should project the weight. I should project the weight. It is clear from the figure that weight projection will be along the direction of motion, okay? And since the angle here, this angle here between the horizontal and the inclined plane is theta, okay? So this will be equal to this angle here, okay? So this is theta also, and this is 90 minus theta. So if I write it here, this angle here is 90 minus theta, okay? So if I want to project W on X, it's W cosine 90 minus theta or sine theta, okay? So when I write my projection, I have W sine theta minus what? Minus the shear force F equals to 0, okay? Now, how can I write the shear force? We know that the shear force can be written as the shear stress times the area of contact, of shear, okay? So I can replace S by what? So now I will replace S by its value. S is the shear force, so I write it here. It's the shear force, and it is equal to the shear stress, which is tau, times the shear area, okay? So let us find the expression of the shear stress and the shear area. First, who can tell me what is the shear stress here? How to find its expression?
The tangential component of W sine theta over A.
Yes, but I want to find it function of V, because I want to relate to velocity. Okay, I will use this relation.
Mu over dy.
Yes, very good. So tau, we know that the shear stress, okay, is, so the shear, sorry. Okay, let me write it here. So I will clear everything. Okay, I will write here that the shear stress is equal simply to mu, which is mu is the viscosity mu times del u by del y. Okay, but what is del u by del y here? So in general, you put del u or del v, let's say, del v by del y. Okay,
it's v over h.
Yes, very good. So if we look at our figure, this is our y-axis. Okay, this is our y-axis, and we have variation of velocity along this direction. Okay, so from here, from this point, it's 0 until this point. So here, if you want, here we have velocity at this point equal to 0, while the velocity at this point here is equal to v. Okay, and the thickness of my oil film is small h. So I can replace dv by dy. I can replace it here by, so I get it's equal to mu times v over h. And now, if I replace back in the equation sum of x, if I replace tau by mu times v over h, I can get a relation for velocity. Okay, so now I can say that the terminal velocity is equal to h times w times sine theta over mu a. And in this way, I have expressed my linear velocity at the final state, function of h, w, theta, viscosity, and contact area. Okay?
دكتور أنا ما كتير فهمت ميو في over h.
Okay.
إذا بس فيك تعيد هذا البارت.
Yes, of course. Okay. What is the shear stress? How you calculate the shear stress? From the course material. Okay? The definition of shear stress is viscosity mu times variation of velocity with respect to, so if the velocity is varying in a certain direction, then it's mu times variation of velocity dv over dy, which is the variation in the direction of velocity. Okay, so here you have v, it's varying along y. Why it's varying along y? Because I will amplify it a little. Okay, so the velocity was first 0, and then it is increasing until v. Okay, so you are obtaining here you have v, which correspond to the velocity at the end of the film thickness. So this is v, while at the beginning of the film thickness, the velocity was 0. So you have an increase in velocity. So it starts from 0, it will increase. And in general, for constant viscosity, we have a linear increase in velocity. Okay? Since it's a linear increase in velocity, when you want to calculate del v by del y, which is the variation of velocity in y direction. Since it's a linear variation, then dv by dy is simply the slope. It's the slope of variation of velocity with respect to y direction. So you can calculate it by delta v. Okay, so it's delta v over delta y. Okay, delta v here is equal to big V, so it's big V minus 0 over delta y, which is the thickness, so it's over h, because the distance here from this point to this one, which is the oil film thickness, this distance is simply what? It's simply small h. Okay, so the velocity gradient is can be simply replaced by big V over small h. Is it clear now?
Yes, thank you.
Okay. Any other question on this problem?
دكتور هون ما بناخذ الفريكشن؟
ما هون what is friction? It's due to viscous effect. Friction here is due to the viscosity of the fluid. This is the friction here. Okay? So if you want, when you have a contact between a fluid and a solid, friction between the two is due to viscous effect.
Okay, thank you.
Okay, welcome.
Doctor, there's
Yes.
questions in the chat.
Yes. Oh, okay. Yeah. Let me check. Okay, so I already repeated what is the shear force. Yes, as for Rawad, yes, as we said, friction is viscous effect here. Okay, so S is friction or the shear force from the fluid on the solid. V over H is the gradient, and we put it as V over H, as you said, Hadi, because it's linear, yes. Now, what does shear stress mean? Okay, shear stress, look, when you have a contact between a fluid, or if you want, not only contact between a fluid and a solid, in any fluid, okay? In any fluid, you have layers of the fluid try to do separation from each other. So when they try to separate from each other, you have the development of forces between the layers of fluids. These forces try to oppose the relative motion between fluid layers. These forces are called shear force, and if we divide by unit area, we obtain the shear stress. Okay, so to understand this better, if you go back to the video done by Dr. Nadim, he gave you an example, the following simple example. You have a fluid, okay, and suddenly you are moving a plate on the top of the fluid. So you have here a small plate, let's say, and you are giving the plate a certain velocity, okay? When you move the plate, you are due to the no-slip condition. What is the no-slip condition? You remember? Whenever if I have at a certain interface, let's say, between a fluid and a solid, if I impose a certain velocity, the particles of fluid here at the proximity of the solid will follow the same velocity of the solid. This is called the no-slip condition. So there is no slipping at the contact line here. So here you have a contact line where you have contact particles between fluid and solid. Because of the no-slip condition, you will have the same velocity at this level. So if your plate is moving at a velocity v, then you are forcing the molecules of the fluids in contact with the solid to move at a velocity of v. Okay? But at the lower level, you have a fixed plate. Because at the lower level, your plate is fixed, let's say, then you have here at the bottom of your fluid, your velocity is 0. So what will happen here, you have inside the fluid, you will have a certain resistance to motion. So not all fluid particles will move at velocity v. due to this resistance, which is through shear forces, okay, and when we divide per unit area, we obtain shear stress. Due to the shear stress effect, you will have a variation of velocity inside your fluid. This is called the velocity gradient. So here, you have, if you take some layers of fluids in the x direction, they will have different velocities. Why do they have different velocities? Because the shear effects inside the fluid will oppose its motion. So this is why the velocity of the fluid will not be V everywhere. No, you will have a gradual variation from big V at the contact with the moving plate until reaching 0 at the bottom. Okay, so hope it's clearer now. Did I answer your question?
Yes, doctor. Thank you.
Okay. Now, shouldn't the direction of the shear be within the direction of motion? No, the direction of the shear is not in the direction of motion, and I will tell you why. Okay? Look, what you are thinking about is the action of your solid on the fluid. So, when the solid is moving at the velocity v, the force it's applying on the oil film will be downward, true. So, this force, which is downward, represents, I will write it here, this is the force of the box, on fluid. Okay? But what you are interested in is the force of the fluid on the box. Because what is your system here? Your system is the box. So by principle of action-reaction, okay, from principle of action-reaction, I want the force of the fluid on the box, which will be in the opposite direction. So this is the force of the fluid on the box, and it's opposing its motion. Okay?
Okay, thank you.
Any other question? Okay. So let us continue. We move to problem 4. Okay. A thin moving plate is separated from two fixed plates by two fluids of unequal viscosity and unequal spacing as shown in the figure. The contact area between the two fluids is A. Determine the force required to move the plate. Okay, so should we think here? Here we have a plate that should move with a velocity v. This plate is in contact with two fluids, one from the upper side and one from the lower side. So here, if you consider the plate as your system, okay, because F is applied on the plate. So I am interested in the system of the plate, okay? This is my plate here. I want to put a force F in order to move my plate, okay? In order to move my plate, I should oppose the resistance of the fluids, okay? Because I have two fluids that will try to oppose my motion, okay? How they will oppose my motion? Through friction, which here is through shear stress, okay? Because here, due to viscous effect, I will have opposition of motion of my plate, okay? So in order to be able to move it, I should oppose what? I should oppose, as you said, the friction done by the fluids through shear forces, okay? So I have a shear force from the first fluid. So the first fluid is applying a shear force on the plate, and the second fluid also is applying a shear force on the plate. And both will try to oppose motion. So the force F I should provide should be able to oppose F1 and F2, okay? So this is F1, and it is the force of fluid 1 on the plate.
Doctor,
And this is, yes? Yes.
here F1 must be equal to the sum of both.
F is equal to the sum of both, yes. F should be equal to F1 plus F2. Okay? Because if you want to move at constant velocity V, then sum of forces on the plate should be what? Should be 0. So the force F should at least overcome the friction of fluid 1 and the friction of fluid 2. Okay? So F should be equal to F1 plus F2. So this is F2 of fluid 2 on the plate. Okay? Now, I can say to be able to move the plate, what is the condition? So F should overcome the friction forces. So the condition is F should be equal to F1 plus F2. Now, how can I find the expression of F1 and F2? Who can tell me?
I use the shear formula.
Very good. I use the shear formula, okay? Because by principle of action-reaction, okay, the force of the fluid on the plate is equal and opposite to the force of the plate on the fluid, okay? And the force of the plate on the fluid is a shear force, and I can write that it's equal in magnitude to the shear stress. So it's shear tau, it's tau 1 times the area of contact, okay, plus tau 2 plus tau 2. So here T represents tau, okay, plus tau 2 times the area. Now, what is tau 1 and tau 2? Now I can go back to my definition.
Mu1 V over H1.
Very good. So for T1, it's mu1 V over H1, and for T2, it's mu2 V over H2. Why I can write this? Because if you go back to your figure, okay, as you can see here, the top plate here is fixed. So here's the velocity, here the velocity is 0, okay? And here, at this level, due to the no-slip condition, the velocity at this level is equal to V, okay? So here, at this level, velocity is V, because the plate is imposing motion on the fluids. And on the bottom plate, it's a fixed plate, and because it's fixed, so the velocity is, here, is 0, okay? So now, if I want to find the shear force in the first fluid at this level here, okay, all I have to do is to say that because I have variation of velocity, so here this is the profile of variation. It is 0 first, then it will increase. So here it's 0 and it will increase until V, while here's the profile, here it's V and it will decrease until 0. So this is the variation of velocity with Y. This is Y direction, okay? So in this fluid, I can write that shear tau 1 is equal to mu1 times V over H1. And it's similar for the second fluid. For the second fluid, tau 2 is equal to mu2 times same velocity V, because here it's a common location. So at this level, you have the same velocity in fluid 1 and in fluid 2 over H2. Okay, so in this way, I can calculate the total force that should be applied on my plate. Any question on this?
دكتور لو واحد من الفيكس بليس عم يتحرك بتغير الفيلوسيتيز V1 و V2 صح او لا؟ وكيف بنحسبها؟
Of course. If the plates are not fixed, they should give you their velocities. So you calculate the velocity gradient. It's very simple. So for example, if they tell you the velocity here instead of 0, if you have a moving plate and velocity is V1, okay? So you do the gradient. The gradient is, you will have V minus V1, okay, over H1. So you go back to the formula. It's the same concept.
اوكي same thing بس انه الفكره
But
بس
instead
V1
of minus 0, you put minus V1. Exactly.
و V minus V2
And of
هيديك إذا
course,
ما
look,
كانت فكرة.
pay attention. If V1 is in the same direction of V, you put V minus V1. If V1 is in the opposite direction, okay, it will
okay.
be V plus V1.
Okay, thank you. Same direction minus the opposite direction plus.
Yes, because or if you want, you can always put minus V1, but you put algebraic value. So when V1
Okay.
is in the positive direction, you replace it by a positive value. And when it is in the opposite direction, you replace it by a negative value. And minus will give you plus.
Plus. Okay.
Okay.
دكتور في problems منهم هولي ولا لا؟ إنه على هذا الكونسبت.
هلا هولي I choose 2 problems on this concept. You can have a lot of problems in the book. You can find a lot. And if you need any help, I can help you with the solution of other problems.
Okay, thank you.
Okay. Any other question on this? Let me check the chat.
Doctor, thank you.
Yes, shouldn't be the direction of shear. Okay, I respond to this question. Abbas, I already respond to the question, is the direction of shear with the direction of motion. It depends on your system, okay? So when you take the plate as system, the force of the fluid on the plate will be in this direction. However, if you take the fluid as a system, then the force of the plate on the fluid, so if you want to represent the force of the plate on the fluid, you will have this one for the second fluid and this one for the first fluid. Okay? Did you understand this?
Yes, I understood and I heard the first time.
Okay. Any other question on this? Okay. So already time is over. Do you have another? So we should stop, I think. Or if you don't have another class, we can continue as you like.
دكتور عنا صفحة 9
Okay.
على
So we will stop here and we will continue next.
Doctor,
Yes.
can you
Doctor,
please
بس
tell Dr. Nadim to
Yes.
ما يعمل هالقد الفيديوز طوال؟
Guys, يعني we will try, but I posted for you the videos on YouTube, so you are not able to download them.
No مش قصة هيك دكتور بس إنه 4-hour video is
يا
not very
دكتور هو
pleasant.
4 ساعات انه
Okay,
بدك
look,
تحسين
let me
ساعة
tell you.
ونص
Let me
ساعة
tell you.
وربع.
هو الcourse material is hard. Okay. يعني حتى in general in class ما كان يكون عندنا enough time to do problems. The advantage in online is that you will benefit from the course material, and we will do in live sessions always we will do problems for you to practice. But because we have a lot of concepts, it's difficult to reduce the length of the video. But what you can do, you can divide your time. So each, let's say each 30 minutes, you can watch 30 minutes and stop. Okay. But we cannot because there is a lot of concepts and he should explain them for you. Okay. So look, chapter 2 is one of the hardest. I understand what you are saying, but chapter 2 is very important and is one of the most difficult chapters. This is why it's very long. Okay. But for example, chapter 1, it's just 1 hour, 40 minutes. So it's equivalent to 1 session and a half. So it's acceptable. Chapter 2 is very long, and in general, at university, it will take us a lot of time. So I don't expect that you watch the video once at a time. Okay. So as we are planning, you will watch, let's say, 2 times per week, 1 hour and a half, 2 times per week. And I will follow with you doing problems. I will follow up with you doing problems. So now nearly we will spend all September doing problems on chapter 2 mainly. Okay. So you don't have to now finish chapter 2. You have a lot of time.
اوكي تمام دكتور. Thank you.
Okay.
دكتور كان عندي سؤال بس هيدا اللي كنا عم نحله.
Yes, sure. Tell me.
نحن حطينا تاو
Yeah.
تايمز اريا صح؟
Yes.
الاريا بس اي وحده يعني where
The area is the contact area between the plate and the fluid. So here, if I want to illustrate it for you, So let's say you have a width B inside the paper. This is width B, let's say. Okay. So if this is the width of the plate, so let's say the width of the plate is B, and you have the length of the plate is L, then the contact area will be L times B. Okay. So in this case, contact area will be equal to big L times big B. Okay.
Okay, thanks. شيلها.
Any other question?
هتنزل بعد problems on chapter 1 أما بس full.
بعد في yes, there is يمكن بعد في 4 problems. So I think next time we will finish with problems with chapter 1 and we can start with problems with chapter 2 next week. So Monday we will continue problems on chapter 1 and Wednesday we start chapter 2.
بس فيك تنزلهم please مع solution.
Yes, I will of course.
أي متى لازم نبلش نحضر chapter 2؟
فينا نقول during the weekend. Okay? So during the weekend we can start chapter 2. بس أكيد يعني 1 hour. Let's say during the weekend watch 1 hour of chapter 2. It will be fun. Okay? I will update you. I already posted a schedule. Okay? I posted a schedule on Blackboard to divide your time. So we expect in general we give for chapter 1 week nearly. Okay? And for chapter 2, it's more than 2 weeks for chapter 2. 3 weeks nearly. Okay?
This recording meeting will be posted in Blackboard?
Yes, I will post it on Blackboard. Yes.
Thank you, Doctor.
Any other question?
Thank you,
دكتور
doctor.
البي هي الويدث للبليت.
Yes, B هي الويدث للplate و L هي length of the plate. So the contact area between the plate and the fluid is B times L.
اوكي.
Okay. Okay, guys. So see you on Monday, hopefully. And if you have any question, you can contact me anytime you want through WhatsApp.
Okay, bye, doctor.
Bye bye.